Okay, so what we're going to talk about right now is inclined planes and how do we make calculations on inclined planes. So an inclined plane is nothing more than a ramp. Okay, so this is an inclined plane. Okay, and so this will change a little bit of how we do things just because the angles change a little bit, but really otherwise not much will change. We're still going to use F net equals ma. We're going to still use F net equals the sum of all the forces. All that's really going to be the same. So if I place an object on this inclined plane or ramp, like so, I get something like this. All right. Now, the other day, you're supposed to do a simulation, all right? And this simulation looks like this, okay? And so what you see here is we have some object that's on the ramp, the inclined plane, all right? And I have the free body diagram over here in the upper left here shown here, right? And what we see is we got the force of gravity coming down. The normal force is over here at this angle, and then the sum of all the forces, or what we would call the net force, is right here pointing down the incline. So if I were to let this play, the net force being down the incline, it would slide down the incline. Now I'm going to show you how we get to that here in a second, all right, and show you what that means. Now, one thing I want you to watch though, and remember the normal force here, remember normal means perpendicular to. So the normal force is perpendicular to the surface. So if the ramp is here, it's perpendicular. Watch what happens if I change the angle. If I change the angle, the normal force's angle changes as well, right? It stays perpendicular to the surface, right? Remember, that's how hard the two surfaces are pressed together, and it's perpendicular to. Now, when I change the angle, I want you to watch the force of gravity. All right, so watch the force of gravity. When I make the angle here small, right, is the force of gravity, is it any different than when it's here? The answer is no, it is not. The force of gravity stays the same. So what's nice about this is that Fg still equals mg, right? That's not going to change. And so your true weight is still the same, even though you're on an inclined plane. Now, the normal force, how hard that ramp and the object pushes against each other, that will change due to the angle. Because if I make the angle smaller, you notice the normal force gets much bigger. If I make the angle, and this net force gets much smaller. And if I make the angle very large, the normal force gets smaller, the net force gets much bigger. Either way, the force of gravity stays the same. So the force of gravity is not dependent on the angle. The normal force is a little bit, and we'll show you how we find that here in a second. All right, so when I'm referring to an angle here, I'm referring to this angle right here. All right, so that angle right there is the angle that I'm referring to. That is the angle of the incline. Okay, now we will call that angle theta. All right, so that is angle theta. Now, if we're drawing a free body diagram for this, okay, the force of gravity would come straight down. Pretend that's straight down. Okay, straight down like so. Now, because it's straight down, it does make a 90-degree angle with the bottom of this if the bottom is flat. It's supposed to be flat. Okay. Now, that force, remember we can add forces or vectors together to be components. All right. So this vertical force here, so this vertical force can be made of components, all right, um, that are not set at typical 90 degrees. All right. So if I wanted to, and I'm going to change the color to demonstrate this. Let's go blue. All right. This would be this force plus this force, right? Those two forces added together would give me that force. It would also be this force plus this force, right? Any two forces that end up there are the sum of those two forces. Now, here's the problem with FG, and this is FG, being there, is that everything's set at this angle and it is not set to that angle. And so that makes things a little difficult. So what we want to do is we want to draw components of gravity that are set at 90 degrees to this angle here, to this angle that we've risen the incline. So what we will do is we will draw one component that is perpendicular. So this is perpendicular to the incline. And we will draw one that is parallel to the incline. So this component we call the perpendicular component, and this component we call the parallel component. All right. Now, if we do a little work here, okay, if this angle here is theta, that means that this angle here is 90 minus theta. All right. Now, if this angle here is a right angle, it means that the other side of that is a right angle. So if this angle is 90 minus theta, what does that mean? This angle in here have to be, that little blue angle there is theta. So our angle of the incline right here is equal to our angle between the force of gravity and the perpendicular component of gravity. Okay? Now, in this triangle, keep an eye out on what everything is. The force of gravity is your hypotenuse. The force of Earth perpendicular is adjacent, and the parallel component is the opposite. So if we were developing equations for this, if we were going to do some math, we would say that the sine of theta is opposite over hypotenuse. Opposite would be the parallel component divided by FG, or that parallel component is equal to FG sine theta. Now, remember, FG is equal to mg, so this is the same thing as saying mg sine theta. We would also know, and I'm going to move this a little bit, we also know that cosine theta would be adjacent or force perpendicular over FG, or force perpendicular is equal to FG cosine theta, or again, mg cosine theta. Now, why does this matter? Well, this matters because, and I need to erase this because I'm going to need to draw on this a little bit more. Because remember, the normal force is perpendicular to the surface, so it comes off this way, like so. This is F norm. Well, what do you think F norm is equal to? It's not equal to FG. They're not in opposite directions anymore. What is F norm in the opposite direction of? F norm is in the opposite direction of F perpendicular. So F norm is now equal to F perpendicular, that perpendicular component of gravity. So if an object is sitting on an incline, the normal force is equal to the force perpendicular. Those two will balance each other. They're in equilibrium. What's left is this component right here, which we will call, so this right here, which we will call the pulling force of gravity. So this is F pull, which we say is the pulling force of gravity, which is this parallel component right here. And this ends up being, if there's no friction, F net is what that ends up being. Okay. Now, there is going to be friction in these problems at some point, and that is why being able to calculate F norm is so important, because as you know, the equation for friction is FF equals F norm times mu. Okay, so you have to be able to calculate that right there. Okay, so now that you know the two equations for how to calculate F perpendicular or F norm, all right, and F parallel or F pull, all right, we can talk about the worksheet that you're going to do. All right, so the worksheet you're going to do is this worksheet. It's in your packet. All right, and so what you're going to be given is a mass, and you need to be able to calculate gravity. Fg is no different than anything you've calculated before. Fg equals mg. That's not changing. So if you're given a force of gravity, you should be able to work it backwards to find the mass. And if you're given a mass, you should be able to work it forwards to find the gravity. Okay. Now, I do not like FGY and FGX. So for FGY, cross that off and write in F perpendicular. And for FGX, cross that off and write in F parallel, like I showed you. All right. And remember, F perpendicular is equal to F norm. F parallel is equal to F pull, right? And so what you need to do is you just need to fill out this table with what I'm giving you. I'll give you a few things. Use the equations from the video, all right? And solve for everything that's missing, okay? My answer key should be at the front of the room so you can check those. Then work 1, 2, 3, and 4, all right? Until and get good at those, and then practice those. Once you're done with those, all right, you can work on, hold on, I'm looking for your problems. I want to say it's these. Yep, these problems right here. What you'll want to do is you'll want to start working problems from number 8 on up. Now, I will warn you that some of these are more difficult, and some of the ones that are more difficult be like number 18 is pretty hard, and trying to find some of the other ones, but I don't think any of these are coming to mind real quick. So any like 8 through 18, any of these would be excellent preparation for the quiz that you're going to take on Thursday. Again, my answer key is online, and so you should be able to find that with those problems worked out. All right, good luck. And then when I get